Hello guys, welcome to Code Clashers. In this video, today we are going to discuss about one of the famous sorting technique, that is bubble sort. So what is bubble sort? Bubble sort is an algorithm used to sort an array, and bubble sort is very important, and this will be asked in many rounds of interview, and also you can expect some questions in your MCQ round. So let's try to understand what is bubble sort. In order to understand bubble sort, we'll be considering an array that is not sorted, means the numbers in the array are jumbled and it is not sorted in descending or as ascending order. So we'll be having one example 5 1 3 4 2, and after sorting our array will be sorted in ascending order, and it will be looking like 1 2 3 4 5. So how we'll be doing this? We'll be doing this in three major operations. Like there are three steps in order to perform the bubble sort operation. One is iterations, second is traversing the pointers, third is swapping. So let's try to understand what how to perform these three steps. The first step is iteration. So let's say as in the example we can see that uh, we are having 5 elements in the array, means we are having 5 elements, so we'll be performing 5 iterations and 5 swapping operations. So for example, if we have n elements in the array, n is any number, so we'll be performing n iterations and n swapping operations. So let's try to look at the first iteration. So we'll be having the same example, and the main part of the will sort starts here. First, what we'll do is we'll assign a pointer towards the first variable of the array. Here the first element or variable is 5, and we will be checking whether this 5, means the element which we are pointing towards, is greater than its next element or not. Greater than its next element or not. Here we can easily say that 5 is always greater than 1. So we will swap this 5 towards 1. And I think you all know about what is swapping. Swapping means if I have two numbers, we will interchange its positions. So here 5 is always greater than 1. So we will interchange 5 to 1. So now after changing 5 to 1, our array will look like 1 5 3 4 1. So this operation got placed, and we will be moving our pointer towards the next element. Here we will be moving our pointer towards the next position. As we know, we swapped 5 to 1, so it will be pointing towards 5, but in second position. So here we swapped 5 to 1, and here we will perform the same operations. Means here we will check whether our element is greater than the next element. Here we can see that 5 is greater than 3. So we will swap this and we'll move the pointer like this. Here the pointer will point towards 5, but in different position. I think all are getting to it. First we will point the pointer and we will check whether the element which we are pointing towards is greater than the next element or not. If yes, we will swap, or else we will leave, and afterwards we need to move the pointer. So here we performed till the third pointer. Now we will check whether 5 is greater than 4. Obviously 5 is always greater than 4. So then we will swap, interchange the position of 5 and 4, and we'll move the pointer. Here the array will look like this, and we will move the pointer towards the fourth position, and we will perform the similar operation. We will check whether 5 is greater than 2 or not. Here 5 is always greater than 2, so we will interchange this position and we'll move pointer towards 2. And after moving the pointer towards the last position, we can say that our first iteration got over. When we will get to know that our first iteration got over is, here we are traversing the pointer from first element towards last element. When the pointer points towards the last element, we can say that it is the end of the first iteration. So it is the end of the first iteration, and you can observe a thing of that first iteration. we can clearly say that the maximum of this jumbled array, what is the maximum of this jumbled array? The 5. We can see the 5 is in last position, means what is the original position of 5? Like if we write the sorted array, the positions are 1, 2, 3, 4, 5. So what will be the position of 5 at last, right? So we can say that after performing the first iteration, we can place the maximum element in its original position. So this is first iteration, and how many operations we perform? 5 operations. Means n iterations, and in each iteration we will perform n operations. So this is first operation, and we'll got the maximum element in its original position. So let's try to look at the second iteration. So after watching the first iteration, we can carefully see that, and in the second iteration we can say that, as in first iteration we got the maximum element in its original position, that is 5. After performing the second iteration, we'll be getting the second largest element, and we need to put it in its proper position. Means the second largest element is 4, and we need to put the 4 here. Means we need to interchange, we need to perform operations, and we need to put 4 here. Means we'll be putting the second largest element in its, means n minus 1th largest element in its original position. So and one thing is, we know that we perform the operations and we put the maximum element in its original position, so we need not to change it. Means we will exclude the 5, and we will perform operations on the remaining part. Means 5 is at its original position, so we cannot able to change it. So we'll be taking the remaining part, and here in the second iteration we'll be doing the same thing. Means like we'll be initializing the pointer towards the first variable, and then we will try to check whether it is greater than its next element or not, and then we will move the pointer. Like we will be doing the same operations, but with one element less. So first here in this second iteration, we initialize the pointer towards 1, and then we will check whether 1 is greater than 3. No, 1 is not greater than 3. So we will leave it, and we will if it's greater than 3, we are swapping it, but here it's not greater than 3, so we will be leaving it, and we'll be moving the pointer towards next position. So here we move the pointer towards 3, and 3 is not greater than 4, so we will leave it, and then we'll move the pointer towards 4. Now 4 is greater than 2, so what we'll do is we'll swap 4 and 2. We'll push 4 towards its original position. Means it's always greater than 4 is always greater than 2, so we'll interchange it, we'll swap it. So after swapping, we got to know that the 4 is in original position. Means after swapping, here what we can say is the first largest element is at original position. After performing second iteration, we can say second largest position is always at its original position. Here we can observe a pattern. Here how many operations we perform? 4. How many operations we perform? Sorry, here we perform 5 operations. Here we perform only 4 operations because we are excluding 5. So I think you are understanding the pattern. First we will check, we will initialize the pointer, we will check whether the element is greater than the next element, if we swap or else leave, and then move the pointer. We'll be doing this, and as explained, as I explained in the first iteration, we can say that when the pointer comes towards the last element of the array, we can say that second iteration is over. So now let's try to move towards the third iteration. Here what we need to perform the same thing. Here we need to exclude the 4, and we need to take only 1, 3 and 2, and we need to perform the same operations. First we'll be pointing the pointer towards the first element. We'll be checking whether it's greater than the next element or not. If not, leave, or else then move the pointer. We'll be moving the pointer towards 3, and here we'll be checking whether 3 is greater than 2 or not, and we can see that 3 is always greater than 2. So then we will be swapping this and moving the pointer towards the last element. So we can say that uh, we have performed all the operations in the third iteration. Means here we perform 5, 4 and 3 operations, and the pointer is pointing towards the last element of the array. So we can say that third iteration is over, and you can see the maximum element is at, means the first maximum element is at last position. Means uh, in this, which is the maximum element 3, what we get, what we change the position, means we have put the maximum element in its last position. Here 5, 4, 3. I think you are understanding the pattern. Now we'll move towards the fourth iteration. Like as I told, we will be excluding the uh, maximum element, means we'll be excluding 3 and we'll be only uh, worried towards the remaining part. So as we know, if we perform the operations in the fourth iteration, we'll be getting the same array, because 1 is always lesser than 2, and after moving the pointer towards 2, the iteration will complete. So we'll be performing the fourth iteration in that way, and afterwards we'll perform the fifth iteration, as only we have one element in fifth iteration. So we cannot able to perform the operations, and we can conclude that we performed all the iterations, and in each iterations we performed n to 0 operations. Means we performed 5, 4, 3, 2, 1 operations. Like this, we, as I told in the first minute, we'll be doing this in 3 steps: iterations, operations and swapping. So we made and we assigned all the maximum elements to its original position, and this is how our final answer looks: 5, 4, 3, 2 and 1. If we combine that, we'll be getting the final answer as 1, 2, 3, 4, 5. I think you all have understood the logic part of the bubble sort, and how we can code this. Let's try to think how we can code this. We perform iterations and we perform swapping operations. So if we can carefully think, we can perform this by using 2 for loops: one for iteration, one for traversing the pointers, and swap operations. So let's try to see how we can perform in code. First we will check the time complexity and space complexity of bubble sort. The time complexity is big of n, where n is the number of elements. Here the number of elements is 5, so big of 5 will be the time complexity. And the if someone asks what is the time complexity of bubble sort, we need to tell big of n, and the space complexity is big of 1, because we are not using any auxiliary or extra space. So this is all about the logic part. Let's try to look the code part. So here I will be explaining the code in Java. So this is, we are initializing the class, and we are writing a function called bubble sort. In this function, our the logic which I have explained is explained in this function. So as I told, we are using 2 for loops: one for iteration and one for traversing the pointers. So how many iterations we did? 5 iterations, right? So what will be the value of 5? N 5. So we will be looping the for loop till fifth iteration. So this is for iteration, and this is for traversing the pointers. As you can see that we are pointing the pointers towards all the elements. So what we'll do? So we need to perform those operations in each iteration. So we perform the iteration, and we initialize the pointer, Now what we need to do, the main part of the code is checking whether the element which we pointed towards is greater than its next element or not. See here, if array of j is greater than or equal greater than array of j plus 1, the element which we are pointing is greater than the next element or not. If yes, swap it. I think you all know how this code works. It just uses third variable and it swaps the two positions. Now like for iteration 1, we'll be performing 5 operations, means 5 times the internal loop will run, and if the element which we're looking for is greater than the next element, we will swap it. So likewise, this is the simple code. I think if you try to dry run this code by using the same example which I have given by this for loop, I think you will get to know how this code works. Just we'll be using 2 loops, one for iteration, one for traversing the pointers, and one to swap. And the main logic of this is array of j is greater than array of j plus 1. So this is nothing. It is a printing function. It is not necessary, and we will be calling the object, and like we can put any array here. In this case, my array was 1 5 1 2 3 4 3 2, I guess. Yeah. So if we call the objects and if we run this function, we can run this function in any kinds. So if we run this function, we'll be getting this output. I think you have understood why I have written this 2 for loops and swap operation. Here you can see one for loop, second for loop, and swap operation. One to iterate from 1 to 5, 2 to iterate from 0 to n minus 1, and we got to know that our array has been sorted. So by performing this, by running this code, we can find out the final answer. So this is all about the bubble sort. I think you all have understood the coding part and logic part. Thank you for watching this video. I will see you in the next video. For more updates like this, please subscribe Code Clashers and hit the like button.